friends, welcome to the session on data structure. In this session, we will be discussing push and pop operations on the stack data structure. As far as this session is concerned, we will see how to perform the two basic operations on the stack. One is called as a push and another is called as the pop. Friends, I am recording this session for PSS Central Institute of Vocational Education for the course Junior Software Developer. And these are the sessions on the unit data structure. But students from other faculties or students from other courses can also learn from these sessions the topic of data structure. So let us start the session and let us understand what we mean by push operation and pop operation on the stack. So friends, push operation, as far as the push operation is concerned, you will find that the push operation is frequently needed on the stack because this is the operation that is used for insertion or addition of data element into the stack. As shown in this diagram, one can easily observe that stack is like an cylinder where the lower end is a closed end and the upper end is a open end, and it has a pointer. Every stack has a pointer, and this pointer is being called as the top pointer. So initially the top pointer will be pointing to the lowest element, and the lowest element will have the index 0. Now you will find that there is no element in the stack, and therefore such stack is being called as an empty stack. Now when we want to add any new element into the stack, then we need to check out what is the position of the stack, and according to the position of the stack, we can go to that memory location and we can insert or we can add a new element. Now when the new element is added into the stack, then the position of the top pointer is being incremented by 1. It depends upon what kind of element you are adding into the stack. Say for example, if you are adding a character, then it will require only 1 byte of memory location. But if you are adding integer, then it will require 2 bytes of memory location. If you are adding any real number, then in that case, every real number will require 4 bytes of memory location. And accordingly, top pointer will be incremented either by 1 byte or by 2 bytes or by 4 bytes. So whenever you go on inserting, as shown in this diagram, one can easily observe that as I go on adding the 11 number, then the top is being incremented. If I insert another element, then again the top is being incremented. So this process goes on. So top will always point to the topmost element of the stack. And also when we add 1 into the top, then that memory address will give us the vacant memory location where the next element can be added. So insertion or addition of the data element into the stack is very basic operation, and that is frequently needed to perform on the stack. And this basic operation is being called as a push operation. So as its name indicates, push means we are pushing or we are inserting the element into the stack. So let us understand how we can perform this push operation or how we can write the algorithm for push operation. So the step 1 is that you have to see whether your stack is in a position where the new element can be inserted, because every stack will have a certain amount of memory, and if the stack is already full, then you cannot add a new element into the stack. So first of all, check whether your stack is full or not. If the stack is full, then automatically error will be generated by the algorithm and will not be in a position to add any new element into the stack. But if the stack is not full, if there is some empty space, then it is possible that you can add the new element into the stack. In such a case, you need to increment your top pointer by 1, and it will point to the next location where we can add the new element. As I said, top, as its name indicates, it will always point to the top of the stack. And whenever you increment top by 1, it means that you are pointing to the next memory location where the new element can be added. Now you can insert the data element or you can add the data element by using the stack location. And Once you added the data element, then finally you can return the success. So these are the simple 4 steps that one need to follow whenever we want to add any new element into the stack, and that is being called as the push operation of the stack. Now let us understand this by taking some example. Suppose I have been given a stack. Suppose my first element of the stack is 15, my second element of the stack is 25, my third element of the stack is 5. Suppose there are 3 elements into the stack. This is my stack, and my pointer top will naturally be pointing to the top of the stack, means to the element 5. Now I know that there is an empty space available in the stack, so I will initially check whether the stack is full or not. But as far as this example is concerned, one can easily observe that there is some empty space. And as there is an empty space, what I will do is that I will increment the top by 1, so that the top now will point to the next location. And now here I know the location, and therefore to this location I can add some new element, say 75. So this is the way you can add the new element into the stack, and this is the basic operation that is frequently needed whenever you open a stack into the memory. Another operation that is frequently needed on the stack is being called as a pop operation. So pop operation means removing an element from the stack. Suppose you have been provided with the stack as shown in this diagram. Suppose there are elements A, B, C, D and E. Naturally, your top pointer will point to top of the stack, and this element is the element E. Pop means removing or deleting the element from the stack. So whenever we want to delete some element from the stack, then in the stack, since the structure of the stack is such that its lower end is closed and its upper end is open, and therefore whenever we want to perform any deletion operation or pop operation, then it has to be performed from the top of the stack only. And therefore whatever is the top of the stack, isn't it, that element you can remove, and you will find that this element can be removed. Say for example, if the top of the stack is pointed by the element E, then the element E can be removed from the stack. If you want to remove in between, anywhere in between the 2 elements, then in that case also what you need to do is that you need to remove first of all earlier elements on the top of the stack, and then remove the particular element, and then later on you need to add the remaining elements again back onto the stack. So this is the way the pop operation can be performed on the stack. So let us write the algorithm for performing pop operation on the stack. Initially what you have to do is that you have to check whether your stack is empty or not, because many times what happens, if there are no elements into the stack, then there is no question of deletion of any element from the stack, and therefore if the stack is empty, the operation will not be performed. But if the stack is not empty, then in that case you can perform this operation. So initially always check whether your stack is empty. If it is yes, then you put an error or you output an error that the stack is empty and stop the operation or exit the algorithm. But if it is not, then access the data element which is at the top of the stack, and then you have to decrease the value of the top by 1. And in this way, by using the position of the top, you can delete the element on the top of the stack. If you want to delete in between of the elements, then that is also possible. For that, what you need to do is that you need to properly position the top pointer of the stack, and finally you can return the success. So let us understand this algorithm by taking some example. Suppose I have been given a stack, and suppose my stacks is consisting of some integer data elements. Suppose the first element is 25, the second element is 75, the third element is 23, and the fourth element is 39. And naturally the pointer top will be pointing to the top of the stack, that is, it will be pointing to the value 39. Now initially I will check, as per this algorithm, I will check whether my stack is empty or not. As far as my example is concerned, one can easily observe my stack is not empty, and therefore I will not exit and I will perform the deletion operation. Now I will access the data element. Whatever the data element that you want to remove, you can access it by using this top pointer. Top pointer will always point to top of the stack. If I want to remove the top of the stack itself, then the pointer is already pointing to it, and therefore I can remove it. That is, I will decrease the top value by 1, and now the top pointer will point to the number 23. So when you change the address of the top pointer, then itself will cause a deletion operation, because now top of the stack will point to the 23, and this 23 now becomes the new top of the stack. As I said, if you want to delete any in-between elements, then that is also possible, but for that you need to move appropriately the top of the stack to that particular element. So when you perform all these steps, then finally we can say that we have successfully deleted the element from the stack. So thank you friends for viewing the session. Hopefully you have understood what we mean by the push operation and the pop operation on the stack. Thank you all.